Hi dear students, welcome to Mahila Samaja online class. Now you are all watching 9th standard science subject. In this, we are going to study about force and law of motion. Okay, in this specifically in this class, where I am going to teach you first and second law of motion. Okay, students, all of you know, right? Okay, so in this class, so these are the important points we are going to learn in this. First one is introductions to the force. Second one, balanced force and unbalanced force. Third one, first law of motion. Fourth one, second law of motion and its mathematical formulation. And final one, problems based on second law of motion. Okay, students, you have a curiosity with you are listening my voice. Yes, now we can study one by one. Let us study first one. It is introductions to the force. You know, students, already you have learned these things in the 8th standard. Once again, you should have to recall this. Force means what? In everyday life, we observe that some of the efforts, it means some of the activities we are going to do. It means it is required to put a stationary object into motion, into motion, or to stop the moving object. What I am explaining, dear students, in our day-to-day life, we can observe or we should have to see outside as well as experience with us some of the efforts ಅಂದ್ರೆ something what we are doing ಅಂತ okay that is required ಅದಕ್ಕೆ ಬೇಕು ವಾಟ್ ಇಟ್ ಈಸ್ ಅಂದ್ರೆ ಸ್ಟೇಷನರಿ ಆಬ್ಜೆಕ್ಟ್ ಇಂಟು ಮೋಷನ್ ಅಂದ್ರೆ ಸಮಥಿಂಗ್ ವಾಟ್ ಆಬ್ಜೆಕ್ಟ್ಸ್ ಯು ಶುಡ್ ಬಿ ರೆಸ್ಟ್ ದಟ್ ಆಬ್ಜೆಕ್ಟ್ಸ್ ಯು ಶುಡ್ ಹ್ಯಾವ್ ಟು ಮೂವ್ ಇನ್ ದ ಮೂವ್ಮೆಂಟ್ ಆರ್ ಸ್ಟಾಪ್ moving object or you should have to stop the moving object. That is nothing but a force. Okay, so just observe this diagram. So one boy is pulling the door, is it right? Another boy is pushing the door. So simply you should have to say your force is pull or push of an object. Okay, so next one it is, so just you can observe this girl is hitting the ball by hockey stick, right? So here just pressing the ball, what it is indicate just objects which are under stationary, it means which are under rest, it should be movement. So second one is, so if the moving object just we should have to stop. Okay, so next here the object should be changes its shape. Okay, these are the effects of the force also. All right, so next one it is, so here just also you can observe some of the activities. He has pushing the car, he is riding a bicycle, he is hitting the ball. Some of these examples for the force. Okay, students. So next it is, the above efforts basically done by our muscles. It means some of our body is contact with the an object. It is called as a so muscular force or muscular effect, and say that we must be push or hit or pull of an object to change its state of motion. Do you understand, students? Right. Okay. Next it is force. Force is a physical quantity which can be changed the state of rest or motion of an object or push or pull of an object. So its SI unit is Newton. Because of the Mr. Newton, a great scientist, he has found out this. So in the name of his, we are always remembering this. Force is SI unit is Newton and it is denoted by capital N. Okay, students. So do you understand this force? Force is nothing but what? Force is a physical quantity which can be changed in the state of rest or motion of an object. So simply you should have to say push or pull of an object. Okay, students. So next, move on to the next point. So that is balanced and unbalanced forces. In the nature, many types of forces are there. All these forces we should categorize in these two groups. That is balanced as well as a unbalanced force. First one, I am going to take a balanced force. Equal forces are acting on the object. Keep an object under same position is called as a balanced force. Balanced force means a equal forces which is acting on a object. Okay, so then that object cannot be changed its position. It cannot be moved anywhere. So that is called as a under same position. It is called as a balanced force. Let us observe this diagram. So here this left hand side 500, this right hand side 500. So this is balanced. Okay. So next here also. So both the sides, the persons we are putting a same amount of energy on that box. Box cannot be moved anywhere. So okay. So here also. So this is F1 is your force. F2 is another force. So equal forces acting on the box. Box cannot be moved anywhere. It should be in the same position. It is called as a balanced force. So next one is unbalanced force. Two unequal forces acting on an object, though which can move in a direction opposite to the greater the force applied on it. It means what? So if you apply unequal forces, the object should be moved towards the greater force. Is it correct? Right. So next it is, just observe this. This is unbalanced force. Here 4 persons are pulling this side. LHS is 3 persons are pulling. So 4 persons, they are putting the more force. That's what. So this tug, it should be moved towards the 4 persons, right? So hence it is unbalanced force. So next one it is here. This right side, left hand side person 6 Newton of force is applying. So RHS, right hand side person, is applying 3 Newtons of force. So it should move towards the LHS because of he is putting 6 Newtons of force. Okay. So next here, so unbalanced force, many examples we should take like this. Okay, students. So next move on to next one. It is first law of motion. So these laws basically put forward by a great scientist, that is Newton. These laws of motion is also called as a Newton's law of motion. Okay, student. So an object, its statement is an object remains in a state of rest or of uniform motion in a straight line unless compelled or disturbed to change that state by an applied force. It means what, students? So if cannot apply any force until that object, it should be in the same state. It means rest or uniform motion. It should be moving unless we should apply the applied force. Okay, then only it should be changed its position or state of rest or motion. That is called as a first law of motion. Okay, so in other words, all objects resist a change in their state of motion in a quantitative way. The tendency of undisturbed objects to stay at rest or keep moving with the same velocity is called as a inertia. This law is also called as a law of inertia. Also, we can call it as first law. So for this, just observe this diagram. So there is a this is a slope. If you put any object, it should be rolled down naturally. So here also, this object, it should be rolled towards the up. So here, the plane surface, it should be moving this side as well as this side. So next, one more example here. Say if you take on a glass as well as a paper, put a 5 rupee coin on that paper, just it should also put a force on the paper. Okay, paper should be moved, but coin cannot be moved in the direction. That coin must be stay in the position, but it should be fell down in the glass. This is the best example for the first law of motion. Okay, students. So here, inertia and mass. Inertia is a natural tendency of an object to resist change in its state or state of rest of motion. Okay, so inertia means it is a natural tendency, it means natural capacity of an object to resist a change in its state of rest or motion. Okay, students, inertia of an object is measured in terms of mass of the object, vice versa. It means mass is also measured in terms of inertia, right? That is nothing but a vice versa. Here, important point, heavier objects or massive objects, it can be offer more inertia. It means it can move fast anta. Okay, right. So next it is second law of motion. The rate of change of momentum of an object is proportional to applied unbalanced force in the direction of the force. Okay, students. So it is nothing but what? The rate of change of momentum. Momentum is mass into velocity. Okay, of an object is proportional to the applied unbalanced force. Unbalanced force means So it can move one side, okay, which is a greater force, that side object it can be moved. That is called as unbalanced force. If you apply this unbalanced force, then rate of change of momentum, what it should be applied, so that should be in the direction of the force. Okay, students. So its mathematical formulation is, its proof is that an object of mass m is moving along a straight line with initial velocity u. It's uniformly accelerated to velocity, it means final velocity v, in a time t by application of force. Okay, friends. So initial momentum p1 is equal to m into u. Final momentum p2 is equal to m into v. Change in momentum is proportional to an object p1 minus P2 is equal to mv minus mu. So m into v minus u. It means mass into final velocity minus initial velocity. Then rate of change of momentum, it means proportional, directly proportional to m into v minus t, m into v minus u by t. Okay, rate of, it means it should be included time here. So next, for applied force, F is directly proportional to m into v minus u and inversely proportional to t. Then F is equal to m is a proportionality constant into m into v minus u by t. From first equation of motion, v is equal to u plus at, or a is equal to v minus u by t. Just substitute here. So then F is equal to k into m into a. Okay, I already told k is a proportionality constant. For this, for 1 unit of force, k into 1 kg into 1 meter per second square. A is your acceleration, right? Then the value of k become 1. Then your equation F is equal to k into ma become F is equal to m into a. This is your second law of motion. Its mathematical form is F is equal to m into a. It means it is a product of mass into acceleration, right? Its SI unit is kg meter per second square. Okay, students. So next it is problems based on this law. First question, how much net force is required to accelerate a 1000 kg car at 4 meter per second square? Okay, this is the question. So we have a solution for this. To use the formula, F is equal to ma. So here given, what is given? Acceleration is given 4 meter per second square and m is given 1000 kg. Therefore, F is equal to m into a. It means 1000 into 4, then it should become 4000 newtons of force is required. Net force is 4000 newtons. So one more problem for this. So if you apply a net force of 3 Newton on 1 kg box, what is acceleration of the box? Okay, for this solution, given what is given, F is equal to net force is given, that is 3 Newton, and m is given, mass of the box, that is 1 kg. Then F is equal to m into a. We want to find out here acceleration of the box. Then a is equal to F divided by m. So substitute here 3 Newton by 1 kg. Then a is equal to 30 meter per second square. Okay, so acceleration of the box is 30 meter per second square. So next, one more problem here. A driver accelerates his car first at a rate of 4 meter per second square and then at the rate of 8 meter per second square. Calculate the ratio of forces exerted by the engine. Okay, we have a solution here. First acceleration a1 is equal to 4 meter per second square and a2, second acceleration is 8 meter per second square. Then F1 is equal to MA1 and F2 is equal to MA2. There are two engines, right? So ratio of force exerted by is given F1 by F2, that is equal to MA1 by MA2. So M and M is cancelled. So then A1 by A2. So A1 is equal to 4 meter per second square divided by 8 meter per second square. Then force in the ratio of F1 by F2 is equal to 1 by 2. It means ratio of 1 is to 2. Okay, students. So next, one more problem here. A sedan car of mass 200 kg is moving with a certain velocity. It is brought to rest by the application of brakes within a distance of 20 meter. When the average resistance being offered to it is 500 Newton, what was the velocity of the motor car? Okay, so we have a solution, we have a formula that F is equal to ma. Okay, or A is equal to F by m. By using this, you should find out the acceleration, that is minus 500. See here, brakes we are applying opposite to the moving object. Is that right? That's what you should take here. Your force as a negative divided by 200. So if you simplify this, so we are going to get minus 2.5 meter per second square as a its acceleration. Now we have v is equal to 0. It means final velocity is 0. While we are applying a brake, you should be coming to the rest. Okay, so then s is equal to 200 meter, a is equal to 2.5 minus 2.5 meter per second square. Then you can find out the initial velocity. V is equal to u is equal to question mark. Then by using this formula here, so third equation of the motion, v square is equal to u square plus 2as. So then we need u square is equal to v square minus 2as. Then substitute the values. V is equal to 0, minus 2 into a is equal to minus 2.5 meter per second square into s means what here? Distance offered. It means distance should be covered after the application of brake. It is 20 meter, right? That is 20 meter. Then here minus into minus, it should become plus. This is 2.5 into 2 is 5. 5 into 20 is 100 meter square. A meter square for second square. Meter into meter, meter square, right? 100 meter square for second square. Then v is equal to square root of 100 is 10. Then meter square is there, its square root is meter, and s square root is yes. Hence its velocity is 10 meter per second. Okay, students. So this much you should study in this class. Based on this, please take the homework. First one, it is write difference between balanced force and unbalanced force. Second question, state Newton's first law of motion with some examples. Third question, state and prove Newton's second law of motion. Question number 4, define the terms inertia and mass. Question number 5, which would require a greater force, accelerating a 2 kg mass at 5 meter per second square, or 4 kg mass at 2 meter per second square. Okay, students. So enjoy with the subject. Please be careful. Read and write well in these occasions. Don't miss the YouTube classes. Just you can take this and to improve your knowledge. Best of luck. Thank you.